right, let's continue with our language of kinematics. And in this video, I want to remind you that physics is a mathematical science. It's applied mathematics. And there are some underlying concepts and principles that have a mathematical basis to them. Vectors and scalars come to mind here. As we'll soon see, these words are associated with mathematical quantities that have very strict definitions. And the mathematical quantities that are used to describe motion can be divided into these two categories. So jumping right into it, let's see what those are. Scalars are quantities that are fully described by magnitude, or another way to say that is there's just a numerical value by itself. So a scalar is just a number. Vector, on the other hand, is a quantity that's fully described by both magnitude and direction. And magnitude's a word that sometimes confuses students. No need for that to happen. Magnitude simply means how big something is. So vector tells you the direction of a quantity and also the magnitude, or how much. And if we go back to our example of little Billy, we can look at that. As we discussed little Billy moving to the bus, we noticed that he took this long, windy path that we defined as distance to the bus. Now, if we think whether that's a vector or a scalar, did he have a specific direction during this time? No, he did not. But we could say how far Billy went, what his distance was, but all we have there is just a numerical value. So this distance that little Billy traveled is what's known as a scalar quantity. Now, if we think for a minute for what a vector quantity could be, let's look at the displacement that we discussed earlier. He started from his bed and he ended up at the bus. We had a displacement. Well, if we needed to, we could measure this change in position and come up with a numerical value. But since it's a straight line, we could also do something else. Let me grab my protractor here. All right. Ooh. Now that I have my protractor, if we put the protractor up here, we could also define a direction to this displacement. So if we look here, this is what, I don't want to read this too closely, between 16 and 17 degrees. That would be what? South of east. Or if we did it in a 360 degree fashion, we'd be doing 360 degrees minus 16, which is, let's see, that's how much? Let's see, let's look at that. 360 degrees in a circle minus 16 degrees from 0, perhaps where we started. And so his direction could be 344 degrees if we establish 0 as this point right here. So this displacement then would have both magnitude and direction, which makes that a vector quantity. So I hope that clears that up a little bit for you of the difference between vector and scalar. So scalars have a number only, vectors have a magnitude and a direction.